Okay, it is 1:30 by my clock, so let's get started right on time. Thank you for coming here. Yesterday we had another industry committee organized panel session that was very interesting and engaging and with a lot of participation from the audience, so we're hoping for more of that today as well. So this session is titled Advanced Control in Industry, The Path Forward, and it's organized by the Ifac Industry Committee, which if you haven't heard much about already, you'll hear more about very soon. I'm Tariq with the University of Minnesota. I'm one of the co-chairs of this session, along with Kazuya Asano, seated next to me here. But in fact, let's first go and just give a brief overview of the panelists. So Dr. Asano is with JFE Steel in Japan. His area of expertise and application and theory as well is metal processing. Dr. Philippe Goupil, seated at the far left, is with Airbus. So he represents the aerospace industry, and he's located here in France, in fact, here in Toulouse. And then Dr. Benyamin Grossman is with Medtronic in the United States, and his area of expertise is biomedical. Then we have two representatives on the panel who are winners of the last two Industry Achievement Awards that Ifac awards. It's one of the Ifac major medals awarded every 3 years, every triennium. So Dr. Angeliki Pantazi is from Switzerland, works for IBM, and works in the mechatronics area, and Dr. Jaroslav Pekar is with Honeywell in the Czech Republic and works in the automotive industry. And as you can see, I'm from the University of Minnesota. I spent 30 years with Honeywell, retiring from Honeywell to move to the University of Minnesota just last year. And I've had exposure to a fairly wide variety of application domains and industry sectors. And also our sole academic on the panel, Professor Ricardo Sánchez-Peña from the Buenos Aires Institute of Technology, also has very wide exposure to multiple areas. Okay. So we are very pleased to be here and to share some of our thoughts with you. So what we'll do first is we will have each of the panelists just give a few minutes by way of their perspective. And we've asked the panelists to limit themselves to 7 minutes, with the exception of the two award winners, who are given an extra 3 minutes to tell us a little bit more about their accomplishments, their award-winning accomplishments. And we're going to try and keep to the time to make sure that we have enough time left for discussion and questions and answers. Okay. And then I'll tell you a little bit about plans for the industry committee going forward, and open it up for your interest if you're interested to let us know, and just some brief closing remarks. So next, let me first give you a bit of an introduction to the industry committee, how it got started, and some of what we've done in the last triennium. And some of this is interesting stuff. It's all quite preliminary in a way, so I'll caution you not to read too much in some of the data and results I'll present after this slide. But nonetheless, I thought it was interesting to share with you. So to begin with, just this last Monday, at the Ifac General Assembly, so the Ifac has a General Assembly which consists of representatives from all the national member organizations of Ifac. If you don't know, Ifac's members are not individuals, they are national member organizations, and they are about, if I recall correctly, in fact, 49 of them currently. And so the General Assembly meets every 3 years, and in preparation for this meeting, the Industry Committee had prepared some constitutional amendments to the Ifac Constitution, which is, of course, a pretty major thing to do. And these amendments essentially made the Industry Committee a permanent part of Ifac, which is reporting to the Ifac Council at an ex officio level. Okay? So we are very proud of this accomplishment, but on the other hand, it now puts a lot of burden on us to follow through on this change. So the mission, if you will, of this new industry committee include the following: strengthen the engagement of industry and industry representatives in Ifac activities, enhance the value that Ifac brings to industry, articulate what that value can be, identify the various elements of that value, right? I assume most of us here are involved in the research world, and there's always this question about how can we make research transition effectively to practice, to practical applications, to industry products, services, and solutions. So that's also part of what the industry committee will be looking at. How can we help make this transition? I'm the chair of this committee for the next 3 years. Now, before this committee got started, for the last 3 years, so for the last triennium, and this might give you a sense of just the pace at which things happen in Ifac. So for 3 years, we had a pilot industry committee. And we recruited members through the NMOs, through the national member organizations, through the Ifac technical committees, through some personal contacts. We had about 38, in fact, exactly 38 members, majority of which were from industry, and globally represented, also representing a wide variety of industry sectors. We also established some work streams that addressed various issues, including academic industry collaboration and others. We, in fact, did a survey of advanced control methodologies as well, and I'll show the results of that to you with some caveats on the next slide. Right? So we are now in the process, or will soon be in the process, of constituting the new industry committee, and you can get in touch with me or Kazuya if you are interested, and we can take that discussion forward then, and I'll repeat that call toward the end of this presentation. All right, so I just thought this might be interesting to share with you. So what is it now, a couple of years ago when this pilot committee got started, we said, let's just check amongst the committee members. What is your sense of how much impact advanced control has had in practice? Okay. And so we put together this survey, and the survey had 12 advanced control technologies listed on it, and one, let's call it baseline control technology, PID control, listed as well. And we asked the members of our committee, what is your sense of the impact of each of these advanced control technologies? And they could say it has had high impact in multiple sectors, high impact on a single industry sector, medium impact, low impact, or no impact. Okay? And the results are illustrated here. The only technology which everybody agreed had high impact, the only control technology, is PID control, right? Everybody, there was unanimous, everybody agreed that had high impact, in fact, high impact in multiple sectors. So that's sort of a calibration benchmark for us. Next was model predictive control, 78% high impact. System identification, 61%. Process data analytics, 61%. And then I won't read through the whole list, but as you go down, you'll see that the crown jewels of control theory, robust control, hybrid dynamical systems, adaptive control, nonlinear control, sort of fall toward the bottom, and it's kind of a discouraging story. Now, there's many caveats, as I said, right? It's a limited sample. I think it's also the case that part of this problem is a problem of visibility and perception, not true reality, that there's, in fact, more going on. It's just that even within our community, we don't know about this. And so we'll address some of these sorts of questions later as well. I did write up a blog post on this, which is available on the Ifac blog page, blog.ifaccontrol.org, so there's more results and methodology notes there as well. But this is the sort of thing that I think the new industry committee may well be interested in taking on and doing more thoroughly and publishing it better. Okay. Some of the data that we collected, we were interested in how much participation from industry is there in Ifac, okay? And in particular, in the technical committees of Ifac, how much industry representation is there, and in Ifac events, how many people from industry attend, right? So first of all, this data was very hard to get at. The Secretary does a very good job of collecting data. When Ifac events are held, the chairs of the events send in a report, which has, amongst other things, indicates how many industry participants you had, but not everybody fills that out or fills it out correctly, and so there's a lot of caveats here. But nonetheless, the best data that we could collect from this indicated that we went down from 5.8% of industry membership in technical committees in 2010 to 4.5% in 2015, okay? And industry participation in Ifac events, and here the best data we could compare was between the triennium 2000 to 2002 and then 2012 to 2014. Industry participation in Ifac events went down from 19% to 14%. In fact, let me ask here, other than the people on the panel, how many people here are from industry? Raise your hands. Okay, that's good. That's certainly more than 19% or 14%. So that's yeah, good. Maybe everybody from industry who's at the conference is here. Yeah. Yeah. All right. So and then there was general consensus among the pilot industry committee members that when it comes to talking to their bosses, talking to higher levels of their organization, people don't really understand Ifac or appreciate what Ifac brings. So many things for us to work on. Okay. So that was by way of an introduction, and now we'll move on to panelist perspectives. And since I'm just standing here, I'll be the first one to give the perspective, and then we'll move on down the line. And as I said, we will be doing this in no more than 7 minutes each, except for our award winners. All right. So as I said, I was with Honeywell for 30 years. During that time, I worked in control applications in the process industries, in automotive, in smart grids, in building management, in thermostats, in UAV control, in some flight management system activities. So I feel I have a pretty broad, if not very deep in all those areas, exposure to industry, and was involved in trying to transfer control technology, advanced control technology to our businesses. So just a few notes I have based on my experience. So first point is, well, if you think about technology, and I don't mean mathematics, I think there's a lot of value to doing basic research and doing basic mathematics and even applied mathematics. But when it comes to what we call technology, that its true test is really the real world impact. I personally think that's inarguable, but if you choose to argue with that, it would be interesting to have that discussion. And so the question is, what is the real world impact of advanced control? And actually, there is significant impact. And when we were putting some material together to talk to people in Honeywell and outside of Honeywell, we came up with a chart like this. So I just wanted to go over a few elements here. So this is trying to articulate the value of advanced control in terms that are important not to the researcher, not even to the Honeywell division, but to the customer, to the ultimate end user, to the people who are really seeking to benefit from the technology. So the first row here is the sector is a broad one: oil refining, petrochemicals, oil and gas. There are many example applications in here: gas processing, refineries, ethylene plants, aromatics, LNG, liquefied natural gas, xylene, et cetera, a bunch of others too. Okay? What we claim, based on our experience, is that across all these, in general, something like 2 to 15% higher production can result from advanced control. So advanced control means advanced beyond PID, and really, effectively, it means model predictive control in these cases. For oil refineries in particular, for which Honeywell has fairly large market share, we estimate actually $1 per barrel comes from advanced control. So that's actually huge, really significant. And in fact, especially medium to large oil refineries, model predictive control is now quite standard. And 5 to 20% less energy per unit production. Okay? Pulp and paper. So Honeywell does a lot of systems for pulp and paper. These include cross-directional control systems, machine directional control systems. Here we quote up to 50% higher performance in terms of the throughput at the quality maintained. But also what's very important in this particular industry is the calibration time when you have to make a change in the process or when you first install the system. And it's 50 to 80% lower calibration time over the previous PID-based implementation. And that's really because advanced control is model-based, and just model-based design gives you tools, gives you a systematic way of developing control. Building control, we've done some developments in HVAC adaptive control that are now operating in quite a few areas. We've seen 7 to 33% energy cost savings as well as low setup costs. Then we have some aerospace applications as well, and I think in the interest of time, I'm not going to go through all of these. Some of these are quantified. So in space, for example, you'll see the Orion multipurpose crew vehicle reduced propellant requirements by 20%, military and unmanned aircraft, 4x less development time, so a quarter of the development time than was achieved before then. But in general, and I think Philippe in particular will also talk about some benefits of advanced control in this industry too. Okay? But I think this is interesting information, it's useful information. If you are thinking as a researcher but are interested in what your research could potentially do in the real world, you need to be thinking in terms, also in terms of the right-hand column on this chart. Another industry issue is the industry specificity of control development. Okay, so control is involved in very different ways in different industry sectors. And this chart just shows between automotive engine control development on the left and paper machine control development on the right. And this is taken from a paper then that I and Greg Stewart, a former colleague at Honeywell, wrote for IEEE Transactions and Control Systems Technology, in which we discussed the issue of this transfer of research to practice and what are the issues involved there. And I'm not going to go through this in detail, but at least just on a visual glance, you can see that the processes are very different. And I'll point out one thing that's very different. If you look at the automotive engine control development process, the chart, the flow, starts from engine and desired performance. So you're given an engine, you're given some performance requirements, and then the whole process starts. Okay? On the paper machine control development, the paper machine and the desired performance comes in quite late in the process. Right? And so that's because you do a more generic control development for paper machines, then you provide a tool, then that tool is used on the plant, and then it's tuned for that particular paper machine. Many other interesting implications arise from this, and many other interesting differences between industries too. So for example, in this case, in the automotive case, ultimately you have to certify things and then they're released, then they're out in the field. You may have hundreds of thousands of vehicles running around, and if there's ever any issue with the control, it means a recall. And of course, nobody wants that. In a paper machine control development, you do on-site commissioning, and then there's post-commissioning maintenance. This is running on a place where it's a one paper machine, and the personnel are available on-site to continue to tune or maintain that. So very different sort of models and mindsets and business models, in fact, and requirements for how the control is maintained or not. Okay? And then my last slide, I just, again, want to sort of emphasize this notion that when it comes to business impact, that is a domain aspect. And you need to be thinking in terms of the industry that you're thinking of applying it to. Advanced control, on the other hand, is a cross-domain technology. Okay? Now, this picture is a lot more complicated than shown here. For example, I've said something like commercial aviation here on the left. Well, commercial aviation isn't just one thing. There's engines, there's environmental control systems, there's auxiliary power units, there's avionics, there's a lot of stuff that happens within there. And then there's a lot of overlap between some of these sectors too. But nonetheless, I think this is something to keep in mind, that advanced control is a cross-domain technology, and when industry thinks about applications of advanced control, it's thinking in terms of the particular domain that it's focused on, or the multiple specific domains it's focused on.
So good afternoon, everyone. My name is Angeliki Pantazi. I'm with the IBM Research Lab in Zurich. I'm a research staff member. I'm 15 years there. And my main activity is working with control, with the application in magnetic tape data storage. And recently also I got involved to new forms of computing, like neuromorphic computing, which is not yet linked to control. But in the next few minutes, I would like to give an overview of how basically the control applications fit in the era of big data that is actually shaping our industries nowadays. I think everybody of us experienced that new era of big data with all the data that are created, and there are several studies on that front that they show that there are 2.5 exabytes of data that are created today, and the digital universe, which is the data that are created every day, it is continuously growing and will keep growing with approximately doubling every 2 years. And this amount of data, they are not only growing in size, but they are also becoming more diverse. So there are data that are important, that there can be scientific data, as you see, that they are also keep continuously increasing, but also they can come in different forms. They can be in videos or in text on different other ways, and they are not only created by people, but also created now by the large amount of sensors and the devices that they are connected in the internet, what is known as the Internet of Things, basically. And in this kind of era, there are two big main questions. The first question is like where we are going to store all this amount of data, and we can do that with the most cost-effective way. And the second question is how we can get the knowledge out of this big data, because this is not easy, and it becomes increasingly more difficult. And these two challenges is the goal of two fields that they are as diverse as data storage and cognitive computing. And in the rest of the slides, I will try to show how control can fit in both these industries and play a key role on that. So starting with answering the first question, basically how we can store this large amount of data. One way that it is one of the most reliable and cost-effective way is to store with magnetic tape storage technologies. But in order for these kind of technologies to keep maintaining the cost and keep storing more and more data, we have to push the technologies as much as we can in order to store more and more data in the same half-inch form factor of a cartridge where the data are being stored. And as you see basically on the plot on the top, this is like coming from the INSIC, the International Magnetic Tape Storage Roadmap, that says that in order to do that, the areal density, which means how close we are storing the data, will keep increasing and almost doubling every year. And then we have to push the technologies in far ahead in order to allow that. And basically, one of the ways to do that is to put the tracks very close together in order to store more and more data, and this is where advanced control technologies are coming, because they have to allow the accuracy to move the mechanical parts of the system in order to position on the read and write elements with high accuracy on top of the written tracks, and then we are able to store more data. And the basic control system that it is on the tape that allows that is the track follow control system, that it moves the actuator to follow the motion of the flexible tape medium as it streams in front of the head element. So the main disturbance there is the lateral motion of the tape, but also there are requirements because the tape drive has to comply and operate in different conditions. For example, we have tape drives in ships to correct seismic data, so there are external vibration to that. So in this kind of track follow control problem, there are multiple objectives that they have to be fulfilled from the control system. And not only that, we can achieve the accuracy, but this accuracy has to be maintained for all the parameter space that the tape drive has to operate, but also it has to be robust because it has to operate in a large number of drives that can have variations from drive to drive, but also variations from environment to environment. And here I would like to point out for a kind of problem that it has this kind of many control objective. What is important here is the choice of the correct control technology. And this is the same for every industrial problem. So one of the first important thing is to choose what is the correct technology to apply that can solve the problem efficiently. And for the tape storage system, actually the H-infinity control theory and framework was essential in order to capture all these multiple control objectives and demonstrate good accuracy across all the parameter space. And you can see on the bottom figures that they show how by utilizing advanced control approaches, we can have better performance compared to classical control approaches. But as it was mentioned also before, for the industry, just only demonstrating one point that this control approach may have better performance than a classical approach may be not the only thing that is needed in order to have a successful transfer of a new control technology to practice. And now I would like to share a few lessons from our experience from transferring this advanced control technology to a practical application. And the first point here is, first of all, we have to listen and understand what is the industry and development need. So we have to go and study the problem, the specific problem of the industry and the development, and what are the issues that need to be solved for the future. And that can be done by establishing link with the people and also have access to the infrastructure or data in order to get an understanding of the problem, because this is what it will drive us in order to select what is the correct control methodology to follow. Second, and very important, of course, is we have to demonstrate these benefits of the advanced control, and we have to do that with the accepted metrics that the industry can then easily translate to what can be the impact of that. If they adopt this technology, what can be the impact of that to the specific industry sector. Next, it is always easier to adapt the technology if there is the understanding of the technology there. So sometimes it's more important, instead of presenting what is the math and the whole theory behind the advanced technology, to present what is the intuition of this control and why this kind of intuition and the framework of this control technology can have a better result for specific problems. And last, sometimes there are issues often in the industry on how the difficulty of implementing an advanced control technique in practice and what this involves. So it is also important to develop tools for the proposed algorithms that they can be easy implementable and analyze, but also modify and adapt for future needs. And that's also very important. Because what the industry wants also is not a specific solution for this current time frame, but also to see how this can have a roadmap for the future, from the future of the technology, and can be adapted for the future needs. And that's why for the tape storage work, we have also demonstrated, besides the effect on current product, as you see on the figure on the top, we had this areal density demonstration where we could project how this technology can evolve in the future. And actually from this work, and for me personally, this whole experience of the advanced control in industry was a rewarding experience. Actually, the whole team was honored to receive the Ifac Industrial Achievement Award for the application of these control technologies in nano domains, magnetic tape data storage, and also these kind of techniques are recognized from the industry too because of the impact of the control. Here, an important thing, that the message that I would like to say, that it is important basically to disseminate the information and keep and make the technical results and the impact that they have known to the broad audience, and that a form of that can be by presenting work in a conference. It's important, and also writing journal publication for this. I think I have a few minutes more to go to the last chart. I would like now to, in this last chart, to just show a perspective for the control for new emerging application for areas that yet control is not there known. And that actually links to the industry, because what is interested is to have new solutions for the cutting edge and hot problems that are there. And if control can offer that solution to that, then the industry will adapt. And nowadays, in the terms of the computing, we are moving from the programmable era to the cognitive systems era, where basically the system will have to be able to learn and interact also with people and extend the capabilities of the current system. And in this kind of area, actually, what the research is currently doing is trying to find new computing paradigms new devices, new computing architectures, like moving ahead from the von Neumann architecture of having separate the data and separate the CPU to process, but having new architecture also inspired from the way our brain works, so that the systems basically, they are going closer in terms of power to the 20-watt operating point that our brain operates. And also there are new applications, again, linked with all this big data and getting the knowledge out of that. We believe basically that in this new era of cognitive computing, control technology has also a key role to play, because all of these requirements, all of these setting the multiple objectives and the constraints in terms of power and everything, the control algorithms have a lot to offer, and in that front, important thing though is like to exploit all cross-discipline collaboration, because this is like can be the information that has to be exchanged between computer science, communication, and also control, and figure out new emerging applications where basically control can have an impact. And actually, if we look back, and there's this interesting statement in this paper here that we can see, if we have a look how the control has evolved across the years, basically the technology that it was used in order to implement the control, it was actually has influenced how the control theory has evolved. For example, we can take the analogy that the frequency domain theory had developed when analog computing was there, then state space and so on, when the digital computing was there. The question is now, in the new era of cognitive computing and cognitive system, if there are new opportunities and new ideas how the control can evolve in a more interdisciplinary way. And then there are several applications that one could think here, also interaction with humans and machines, that it can be in automotive or robotic industry. And I think in general, I believe that for advanced control in industry especially, there is an exciting future ahead with many new applications in this area. Thank you very much.
Okay, hello, my name is Ricardo Sánchez-Peña. I've been in the university, working at the universities in the last 40 years. And since my first experiences at Caltech, studying robust control, I started working on theory, proving lemmas, theorems on convergence, stability, performance, robustness, and so on. And I got my first grasp on real problems with one agreement we had with NASA for the X-29 flight control system. So from there on, I continued developing some theory and going into algorithms, and as soon as I started getting some financial aid and some support, I could start buying equipment, so I start moving to applications. Most of two of the main applications I've been involved is in aerospace, and in the last 7 years I've been working for the artificial pancreas. So I think I more or less moved from theory to practice all along the way. It took me 40 years, of course. But I wanted to stop at the particular conditions we have in Latin America. I've been moving around as a visiting professor to the US and the European Union. I spent 5 years in Spain. But most of the time I've been in Argentina and working with colleagues in Latin America, mainly with Colombia, people from Uruguay. And so in Latin America, we have particular conditions that sometimes limit, and sometimes they have advantage conditions for us. One of those particular conditions is the value chain. The value chain, when you start as a researcher and you develop some theory, and then you want to you develop or you produce an algorithm, a control algorithm that it's advanced, and you want to apply it to a particular product or device, and then you want to contact the industrial people, and you want to implement, you want to generate a prototype and a proof of concept that will work in the real world. And from there on, you want to contact the industry so that can be commercialized or can be developed further away. So in all those steps, you need people that will target on a particular problem. And so in Latin America in general, I'm talking in general, I know I have a better knowledge of the Argentinian case, but also talking with some colleagues in Colombia, Brazil, Uruguay, they have similar problems. This value chain is not complete. So sometimes as a researcher, you have to get more involved into what the real problem is. And that's an advantage in some sense because you have a broader idea of what real problems are, although you have to sometimes work in the algorithmic part and in the programming and in developing theory and so on. So that's an advantage. A disadvantage is that you always need more people, or you have to cover the place of several people with different focuses, with different specializations. So that's one of the main problems sometimes, if you can consider that a problem in Latin American countries. The other problem is that high-tech companies, and we are trying to talk about advanced control systems. So there are many companies that have jobs for young engineers where they apply the basic control algorithms like PID that works for many applications, and they work very well. I worked in the aerospace industry, and in aerospace, sometimes with PIDs, you can do a lot of things. But sometimes if you want to apply more advanced control, or you want to make some research, R&D type of developments in industry, there's not such opportunities in general, because industries in our countries sometimes have their representatives in Argentina, Uruguay, Brazil, Colombia, but those representatives only sell products. They don't have R&D departments. Most of the R&D departments are abroad, so you have to go to Europe or to the US sometimes to do some research and development related to a particular application or a particular company. So that's also a limiting factor in some sense. Of course, you can move abroad, or you can go back and forth. That's sometimes what you end up doing. You contact people in your country, then you contact people abroad, you have some collaboration with international partners, and then you end up working with people from other countries. That also happens. And finally, there are some tax advantages for companies to work with university, but that's not really well developed. That's sometimes have been some motions to increase that kind of tax advantages for companies, but it's not a really developed issue. So that should be promoted in the future. So usually when someone wants to apply, or particularly young people wants to apply advanced control, they come from academia, the driving force comes in particular from academia to industry. I've worked, for example, in aerospace like 16 years in a research institute in Argentina, mostly with public funds. Like many universities, university is free in Argentina. And this research institution where we developed our own satellites, and we are developing a launcher for launching satellites. This research institution have created their own small industry to solve particular cases. So that's more or less a short idea of what's going on in Latin America. With that, I will finish.
My name is Benny Grossman. I work for Medtronic Diabetes. I'm a senior principal scientist. And before I dive and introduce the 670G, which is a pump that actually delivers in a auto mode insulin, I'll talk about my background. I had a PhD in chemical engineering, all about nonlinear dynamics, control modeling. Most of my case studies were being in silico, and most of them were being dead things, like distillation columns, tanks. When I got the opportunity to work with Professor Frank Doyles on artificial pancreas, I was thinking it's sci-fi. So basically, applying theory to actually delivers an hormone to a body, and by that, make the lives of people better. And I got into this artificial pancreas community, which is an example, maybe is a rare example of a lot of interaction between industry and academia, because in parallel, Medtronic Diabetes started a program around '99. At the same time, at the end of the '90s, there was a lot of activity in academia, starting thinking about the ground for artificial pancreas algorithms, usually model predictive controllers, while Medtronic focused more into a PAD, but they realized later that just implementing a PAD will not work in this project. So there is a lot of interaction between some of the academic groups become startups. I moved from after my postdoc to the closed loop team in Medtronic, and I helped actually build a lot of the algorithms inside this 670G. And of course, I will not be able to do that without academic background, without me being exposed to artificial pancreas research in the UCSB with Professor Frank Doyle. So let me explain some of the challenges in controlling glucose. First of all, the actuator is very slow. Usually when you eat, let's say it, if people are fasting, the problem is much simpler. But we cannot convince them to fast all the time, and I don't think it's healthy, so we need to handle the meals. The meals appear very fast. Probably in 5 minutes, you can already see the traces. They can peak in 20 minutes. While insulin action, right now, it's being delivered in the subcutaneous, it will peak, the effectiveness will peak in maybe 3 hours, 4 hours, and it can linger for a very long time. So we have a problem. The disturbance is already washed out when your actually effects start showing. So there is, and now making a mistake with this control, of course, making a mistake in a distillation column can be endangering a city, but here, making a mistake can put someone in hypoglycemia, or being too conservative, there is a long-term complications. Now, usually when we have case studies in academia, we have one plant with kind of errors in understanding the models, in the dynamics. In this case, every human is a different plant. Every human reacts differently to insulin. It has different time constants and different gains. A kid can need maybe 10 units of insulin, while an adult can reach 120 units. And more than that, there is an variability. Day by day, things change, your insulin sensitivity change, and usually it changes over the day as well. There is some circadian rhythm that influence the insulin sensitivity, and you need to build a control system that will actually work in this environment, give the value and be safe at the same time, and this is a challenge. That's why it took 2 decades. Let me 2 minutes. Oh my. So the system has a sensor and a pump. Basically, the feedback is coming through the sensor every 5 minutes. Every 5 minutes, you make a decision, and the algorithm is sitting in this pump. I want to emphasize, if I have a minute and a half, about model-based design. Before building a fancy algorithm of control, you need to know that you actually understood the dynamics. Because if you build a very good controller that solves in silico a very fancy problem, but this model is not really representing the reality, it will work only in silico. So we put a lot of effort into virtual patients. We produce around 2,000 virtual patients from data, and this is the base to check the system, the errors. We incorporated our sensor errors. Everything is there. We can use it for checking the user interface, and any scenario that you can imagine, we use it. But the main emphasis is, like, without the virtual patients, just a trial and error on human beings is almost impossible. Some results, we had a pivotal trial. If I mention, this is the first and only product that actually delivers insulin automatically and approved by the FDA. This was after a very successful pivotal trial on 124 patients. What the automation did is reduces the variability in glucose, increased significantly the efficacy. You can see the A1C is from 38% below 7 to 62% below 7. This is the indication of the efficacy, but also the safety was improved by folds. We didn't have any case of hypoglycemia in 3 months and no DKAs. So with this positive note, I'll end it.
Okay, good afternoon, everyone. So I'm Philippe Goupil from Airbus Commercial Aircraft. I will not go into details on these slides. It's some key numbers, some key figures about Airbus, but if you attended the plenary session from Airbus yesterday morning, so you got all the explanation. So by the way, I think it was a very good plenary talk. I'm not saying that because the speaker is the boss of the boss of the boss of the boss of my boss, but that was really, I think, a good plenary session with a lot of information. Just to say that I will talk about commercial aircraft, not about the 2 other divisions, which are the helicopter and the Airbus Defence and Space, launcher, satellite, and so on. And what I'm saying is based on my personal experience. It's not an official statement point of view from Airbus. So the context is that, so more or less, an aircraft is divided in 3 parts. You have the engines, the structure, and the avionics, so all the electronic equipment on board the aircraft. And I will especially focus on the flight control system, which is used to control the aircraft trajectory, speed, and attitude. So it composed about all these elements you can see there. And so the wires, actuators, sensors, and flight control computers, and so on. And we have some specificities, I think, compared to other industries. We are not the only one, but we have some specificities. We have a stringent environment, and especially we work on a real-time critical onboard system. So we need a deterministic system, algorithm. Another specificity is the aircraft life cycle. It was already presented by Charles Champion during the plenary talk. If you look at the software life cycle, we have an update every 6 months or every 12 months, but an aircraft can fly during 30 or 50 years, okay? From the first aircraft which is produced up to the last flight of the last aircraft which is produced, you can have 30 to 50 years. So this is a very important specificities to take into account for the control, but not only for the control. This is the obsolescence, okay, of all the components of the system. That's a big constraint. And the last one is the certification, okay? We are not producing smartphones, so I like smartphone. I need a smartphone every day, but we are producing aircraft with a lot of passengers, and you want, when you fly, you want a safe flight from point A to point B. So we have to certify the aircraft to demonstrate that everything is okay, that we are compliant with the requirements, so that's a big constraint, just to set up the context. And one statement of fact, personally, I think there are a lot of interesting solution algorithm which are produced by the academics, and also a lot of potential solution, potential interesting algorithm. We have a lot of industrial needs, but there is an application bottleneck or a valley of death. We can call that a valley of death. So we need to bridge the gap between all the already existing solution and our industrial needs. Just an example of a success story. We thought that it could be interesting to talk about one concrete application. I will not go into details. This is a project we had with the University of Bordeaux in France. And what is interesting, so I will not explain the algorithm, but what is interesting is that we started with a PhD during 3 years. In France, it's during 3 years. And we went up to the concrete application and certification on the A350 XWB. There is the latest Airbus aircraft. So we use an extended, also modified version of an extended Kalman filter. For us, it is an innovation. So I remember I already presented these techniques during another conference, and I had a question at the end of the presentation. So you said that it's an innovation. It's not an innovation. Kalman filter exists since the 60s, but for us, this is an innovation, okay? Because the implementation is tricky. We have a lot of validation. The tuning is tricky. And so we took 4 years for the industrialization of this modified version of an extended Kalman filter. This is the innovation, not the filter in itself, but the innovation is the application. Okay. And to conclude, some challenges and opportunities. So there is no specific order, okay? No priority. It's like we say in French, a liste à la Prévert, okay? It means that there is no order, no priority. As I said, we have a specific context, so a stringent environment for the development of the algorithm, for the control, for the fault detection algorithm. The second point is the conflict between the industrial short-term objectives, which must be customer-oriented, and the academic long-term objectives, okay? So we are doing business, we need some knowledge as an input, and we need to produce to get money at the end of the story. And I think for the academia, that's more or less the opposite. You need money or business to produce knowledge. So we have two, let's say, open loops, and we need to close the loop between academia and industry. There are some practical considerations to take into account to use advanced techniques in such a stringent environment, either for control, for fault detection. First of all, we need a high-level easy tuning. That's very important, okay? And also the genericity of the method. If we can use a fault detection algorithm on a given control surface on a given aircraft, and if we want to use the same algorithm on a different aircraft for a different context, a different actuator, a different control surface, we need to be able to use the same solution, okay? We don't need to have to call an expert, an academic expert, each time we change the context. So we need an easy tuning and a high-level guideline to be able to use on a daily basis this kind of solution and algorithm. The implementation constraints are already talked about it. For example, we have a special graphical language to produce the software for the flight control computer, and we cannot do what we want with this kind of language. That's a constraint. The next point is about the need to build around existing solution. We don't need necessarily something completely new, fully new, but if we can use an incremental approach, which is to build a new solution around the existing solution, that's okay. Okay, it's better to be certified also. We don't need a fully new solution. Okay. Just another example. If the aircraft flies in the middle of the flight domain, that's very linear. We can use LTI model. We don't need a very complex solution. As you probably know, we use gain scheduling and this kind of stuff. But if you get closer to the border of the flight domain, we have strong non-linearities. This is where some advanced techniques like the adaptive techniques could be useful. But what about the certification? Certifying a gain scheduling controller, that's easy. But if you want to certify an adaptive method, that's another story. So this is a big constraint for us also. And the last things I would like to mention is, of course, the need to bridge the gap between academia and the industry. It was also the topic of the panel session yesterday. What I would like personally to see from the academic point of view is more and more application, concrete application, and also a lot of validations. I'm sorry to say that, but I see too many papers with a golden example, very nice techniques, okay, very complex, a lot of theory, but you have an example on one signal without noise, which is golden example, and the data set lasts only 30 seconds. Okay, that works. But in the real life, that's different. So I would recommend to make more and more validation. Not only the average behavior is of importance, but also what is the behavior of your algorithm in extreme conditions, in severe conditions. And also take time to understand the industrial context and the problems we have to face. And from the industrial side, we know that we have also to provide you with benchmarks, for example. That could be very interesting if we were able to provide you with benchmarks. That's a key point to bridge the gap between academia and industry. But we have confidentiality issue from our side. And that's all for me, just some elements.
Yes, my name is Akbar Khanna. Today, you can see by my age, I've been doing control for a few years. So today I'm my own boss, Barkana Consulting, and it's taken me all over. As I like to present myself, I'm playing doctor and professor, but I'm an engineer. I like to be a simple engineer, solving people's problems. I like those presentations very much. I'm surprised that you on Airbus mentioned adaptive control. If you write my name, if you write simple adaptive control, you'll see my name. I'm doing control, not adaptive control, and many good tricks, many stuff, but things are changing, and even H infinity is very good when you assume that things are fixed, even if they are different from what you think. Once things change, the plane goes here and stays there, but if it must go up and down, the gain scheduling is not very safe. You don't have a proof of stability, and this was my first shock. So I'm doing adaptation, and I dare to say adaptive control in simple. People call me Mr. Simple, and I cannot tell you how many applications are. I see a lot of publications. We had a workshop here, and we had a special session with people from Japan, China, up to Canada, all the way. How many things are already implemented, I don't know. Very serious application. I think for the Airbus, we could talk about some simple adaptations and flexibility, flexible modes. I think I can have some surprises. Thank you.
I don't know if it is a question, but I can say that gain scheduling is safe because we use it for many years. It's certified, so we have millions of flight hours with gain scheduling, so you cannot say it's not safe. So.
Like CID works when you don't ask too much.
Yeah, but it's enough. So what I was mentioning is that we don't need an oversized solution. We need to achieve a goal, and if simple techniques is able to do it, that's okay. We don't need a very complex.
Actually, I had a sort of a follow-up question related to this need for certification and all of that, because I noticed that you, as well as Benny, you, and I guess Ricardo, you might be involved in some of these activities as well. And I don't know in some of these other applications whether that certification has been much of an issue. But is it any significantly different between, say, biomedical devices and aerospace, or what are some of the issues in certification that might be common or different in those, particularly in those two industries?
I don't know for your domain, but for us, we have several levels of criticality, what we call the design assurance level, A, B, C, D, and so on. So the highest level, and the more the constraint you have to prove and to demonstrate the solution.
As a benchmark, how long, if you can say, how long would it take to say the work that you did? Is it a matter of months or years or weeks to do the certification?
It's a matter of months, yes. Months, okay. Several months. We try to reduce it, but it's several months at the minimum.
Yeah, so I never worked in the aerospace industry, but in our case, especially in the US, we have to go to the FDA. As you probably assume, a pump that delivers insulin automatically is the worst class of device. It took us 2 years. it was with a lot of collaboration of the FDA. So FDA wanted this product. They were involved in the clinical trial design. They were giving us feedback before we did things. They explained what are the requirements. They didn't want to make this blind. We're gonna make the best clinical trial we think FDA wants to see, and then FDA will say we're missing stuff. So they were a very they were a partner in a way, in the way we approved this device, but it took 2 years, past 2 years.
So addresses some of the complexity there.
So I wanted to add,
Go ahead.
because I kind of been in both aerospace and also in biomedical. In aerospace per se, we worked on satellites, and we didn't have a certification, but we worked with people from NASA, so we had to have their certification before we launched the satellites, and that took a lot of hours of meetings and tests and more tests and so on. So I think a lot of the budget for the satellite came from testing and simulations and more meetings and trying to test things. That's not a certification per se. In the biomedical, we had a protocol for only 5 patients that we tested last year and this year, 10 days ago, in Argentina, and we have our own FDA called ANMAT, and it took us 1 year to certify through our local FDA the protocol for these 5 patients, so it takes a long time also.
Thank you.
Thank you. I have at least 2 major concerns. My name is Lucia Quintero. I'm from Colombia. I can say that I spent half my life doing control engineering right now. Okay, so I have 2 major concerns. I'm professor at the university. So first thing, from the academy to industry, do we have to start being less poetic and become more practical? And what if we have the proper encouragement to do it? I'm saying this because of us academy, we have this top journal paper publications encouragement, so we are committed to improve our career through journal papers. So do we need to establish a new way to become successful in terms of academy working with industry? And the second concern is about the challenges of these confidentiality issues. Once you start to work with industry, even if you are less poetic and decided to go straight to industry because there are a lot of problems there and you're fully sure there are going to be a really good scientific contribution, what is going to happen with this intellectual property? We have been this discussion with certain universities and companies think that it's difficult to share the intellectual property of products because of from industry comes the problems, the devices, the high tech, and from academy we have these ideas and we cannot quantify it to participate into these kind of projects. Do you have in mind any solution for it? Because we went through a difficult intellectual property committee a few weeks ago, and we decided to ask the company, try to quantify how much are you winning from this development and trying to participate with at least 1% to a new center of development. So it was hard to discuss it, but the lack is we cannot quantify in terms of money, our ideas and our thoughts and our scientific skills. So do you have any idea of the solution for this problem?
So those of you who've had productive academic, if most of the people are from industry, any productive academic collaborations or the other way around as well? Yeah.
Okay, I'll answer then. I think first, with the first question, we don't need to be less poetic. We need to broaden the bandwidth. I think we can continue doing theory. Probably we have to focus more theory. If you want to interact with industry, of course, you can do just theory, just per se, just for aesthetic reasons. But if you are interested in having a relation, a cooperation with industry, I think you can still go from theory and start getting involved in the real problems industry has, because otherwise you are not really, you are kind of talking two different languages, and that's has been a problem for a long time, at least in some of our countries. So I don't know if that answers your question. The second question?
Well, the second question was on intellectual property rights, and
okay. I leave that for the industry people.
Just a comment on the collaboration with the academia. From my personal experience, when we have a collaboration with one lab, for example, it's easier, of course, because we can have, from the IP point of view, we can have an NDA, for example. So it's easy in this framework to provide a benchmark, for example. But the way we proceed, or the way I proceed personally, is also to let the freedom to the academic to develop a complex solution if you want. But what we want at the end, it's, for example, a degraded solution which is useful for us. So I know it's not very sexy for the academic people, but sometimes we need a very simple solution that we don't know, but you know, but you don't like to work on it because it's too simple and you cannot do a publication with this kind of simple solution. But I would recommend to try to provide a simple solution first, starting from the state of practice, as I said, like an incremental approach. If you know the industrial context, you can think about one simple solution, which is just an evolution of the state of practice, and then you can work on more complex solution. But I think it's good for the industrial if you're able to provide very quickly, simply a simple solution. And then we can work on a more advanced, more complex solution. So when we are doing a PhD, this is typically what I used to do. During a PhD, we want very quickly a simple solution, and we let the freedom to the academic people to work on a more complex solution, not poesy, as you said, but a more complex solution. And very often when you understand the industrial problems, it also gives you new ideas on a new scientific problems, so I don't know.
Hi, I'm Junaidam from Paris-Saclay University. I have been working in smart grids, control of power systems, so on, mostly with industry. 80% of my PhD students today are with industry. And I used to go to Congress in power systems, power electronics, and in control systems. When I go to power systems, power electronics, almost half of the presentations are from industry. And here I have seen a bunch of presentations come from industry only. And I was trying to wonder, why does? Is that because industry is not so much interested in presenting, because industry have results in control? So are they not so much interested in presenting in control conference, or is more likely they consider that better to not show so much of what they're doing on that?
So actually my answer to that is that the control community needs to be better at making industry recognize that the extent to which control is a cross-domain technology and the benefits that come from looking at control across different industry sectors. And the chart I showed where I had control as a horizontal band and different industries as these vertical silos. If you're a company working in aerospace, you will think of control within an aerospace context. You won't think of aerospace within a control context. So I think it's quite natural in a way, and I personally think that it's almost to be expected that a large control congress that goes on for a whole week, such as this, will see less industry participation than, say, a control in aerospace conference or a control in automotive conference. I think probably even Ifac control conferences. So I think some of you have been involved in Ifac industry control conference. Some of you have been involved, I think Kazuya, you especially, right, in the M conference. Yeah. How many papers are there from industry, and any others who's, Philippe, you have something to share?
Well, yes, just a comment about the presentation or the publication in a paper or in a conference. Personally, I do not have any problem to present something. Generally, we register first a patent if it is really interesting for us, and then we can publish not all the results, but part of the results. But when you submit a paper at such a conference, which for me is quite theoretical, sometimes the review or the feedbacks are quite negative. They say, oh, it's just an industrial application. What is the innovation? Like for the extended Kalman filter I talked about. So it's not so easy to publish. It's not necessary that we don't want to publish, It's that the standard, the academic standard, are quite demanding for us. So personally, I'm not able to produce a paper with a lot of equations, with a lot of theory, but I can show many applications. So I think there, I'm sorry to say that, but there have to be an effort from the...
Yeah, basically, actually what usually has to happen from the industry people to participate in these conferences for control and not industry-oriented is like that we have to shape our work more on the theory or extend a little bit further the work that what is needed exactly for the product. So it is like sometimes need a bit more effort for that, but it is valuable.
Thanks. Yeah, there's a question here.
So my name is Esko Juuso, and I'm from University of Oulu, Finland, and I work there as a team leader for industrial and energy automation, and our task is to combine, let's say, automation, data analytics, and IoT to give some useful solutions for industry. And there, for this work, this perspectives of panelists, they were very, very valuable. Thank you for those. I have some comments on that, because yes, in principle, we can do everything in a very high level, and we can combine a lot of data. We can also store a lot of data. We can collect it. But what is the practical way of doing all these in such a way that these solutions also work in everyday industry? So if you look at the very high level calculations and control solutions, then we need to have some kind of very compact solutions for lower levels, stabilizing levels. They must be working properly all the time. And it's also the same thing with data, because we could collect so much data, but it must be pre-processed in some way to get it useful. And we are talking about edge computing or local calculations, so that we process data which is a very frequent data. So we can have waveform signals where we have a huge number of values per second, and there we need some features, and we can develop also indices from those features, and then these are very, very useful for calculations. Okay, with those we can go to this conceptual modeling, and but if you do that on the basis of the normal data, then you are in a very bad situation, and then you can also need to use expertise and that kind of things, and they belong to how you organize these all things and how to tune and calibrate everything. So what are the comments on this from the panelists, how these ideas fits to your?
Yeah, I was actually struck by how many of you referred to connectivity, big data, IoT. You know, it seems to be something that's cutting across industries and something that control researchers and scientists need to be more engaged with. And so but you know, there's a challenge there as well, right? So Angeliki, when you were talking about the era of cognitive computing, right? What does that really mean? And I think you just posed it as a question. We don't really know what it means for control, but we do need to somehow get engaged maybe with other communities and figure out what control has to offer. And similarly for some of the others of you. So I'll let you answer first. And I was also, I think, interested in the biomedical side. And Benny, when you were talking about those devices, you know, is that something that's starting to happen as well? So we'll let Angeliki answer first, and then you and anybody else. Yeah.
Yeah, basically, as you said, these are new emerging fields. So the field itself is not a traditional field, so it is not the traditional area where control already has proven the value. But these are new fields that they are now emerging, and they are in the process of evolving. But I believe that the control scientists have to look in these new fields and try to find their control problems that they are definitely there, and that actually will give to the control new applications and put the control in a new position in this new era. And there are many kind of applications in different fields, starting from, as I mentioned, working with the data, or even robotics, that they have learning systems, or there will be new computing paradigms and these kind of things. But the control researchers, so as you said, I don't have the answer to that, but control researchers should look and identify so new methods for control.
I think the burden is on the control community to learn more about these developments and then try and figure out what it means for our discipline. Benny?
Yeah, so I'm going to give an example. So it's very applicable for what we are doing. Think about a very simple controller that sits on an insulin pump and how limited it is. When in the near future we're going to collect each individual data and transfer it into the cloud. Offline, we can do calculations we cannot do online, and we can improve the algorithms or retune it and calibrate them in the cloud and set the settings back or directly to the pump or to the physician. But these things are things that we are currently thinking about.
Okay, Philippe?
Just to reinforce what was said by Jaroslav about the guideline, that's also a key point when we have a new algorithm, to get the guideline, to know how to tune the algorithm for the genericity. I had an example when we had a collaboration with an academic partner. We asked for a guideline, and he sent a publication, an academic publication. So this is not what we want. We want a dedicated document, technical note, or training to know how to tune and use the algorithm for the genericity, which is also a key point.
Thank you.
My name is Carlos Pereira from Brazil. I'm a professor at the university, but also now running a kind of center, a network of applied research center to make this connection, industry and academia. And one thing I think is also related to the previous discussion here is, by the experience we have seen, I think automatic control is pretty much model-centered. We build models, we try to understand, identify, but now more and more with cyber-physical systems, like Internet of Things, people try to be using a lot of data analytics. That means data-driven and machine intelligence. And my experience is several people from industry think that eventually it's going to replace, I would say, the tradition. Instead of doing the model, they always kind of a black box approach. You look for, learn by experience, and suddenly you have a kind of magical solution there that works. And I think that, like, for instance, the IBM model of the Watson that can use that. How do you think that is going to be, I think for the educators, I can see that sometimes people say, why you should be learning there? Because we can do by using statistical analysis or some predictive analysis.
Yeah, I mean, one problem that, as you said, in this new era with data is like the data is the source, the resource, and this is like what it will give at the end, the information. But you mentioned the system, and the Watson and the current cognitive systems, but in all of this system, another issue is like how in the future we can make them power efficient or operate in other constraints, so that the capabilities, they are not only limited to big machines, but they are also something that it can be more utilized in smaller devices and other applications. So it is not only that how we will handle the data, but there are several other things and several other areas where control can have an impact there.
So I'm going to give you my opinion, and I think that machine learning eventually will be able to model and design the controllers automatically. But I think that education is different. And I think by studying control theory, it's not only the benefit, it's not only the applications, even that I'm coming from industry, it's a way of thinking. And this way of thinking can solve a lot of things, even management visions that machines cannot do. So I think the education into theory and hard problem solving is a benefit by itself. And sadly or happily enough, I think the machines eventually will design those control and model for us.
I have some comments concerning the model-based controllers. In my experience, I've been working for a while in data-driven controller and falsified control type of techniques. and also in robust identification, where sometimes you say let the data speak. At this point, I would say that model-based control cannot be replaced by data-driven control. So I think we will have to continue with model-based and probably identification and so on. I don't know in the future. I hope we can get to some point where we can use only the data and not have to go through intermediate steps like having a model or a model with uncertainty or things like that. But at this point, in my experience, after 40 years, I would say that it's still irreplaceable.
I would agree with that, Ricardo, but I will say that in my experience with industry, I see at higher levels of organizations and corporations, people starting to think that, hey, it's all about the data, and maybe we don't need domain expertise anymore. What we need is expertise in statistics and analytics and data mining and all of that. And I think there's a danger there, because I agree with you that we're not there yet, and I'm actually not sure if we will ever get to the point of saying you don't need to know the physics of the problem. Yeah. I think I will ask Sylvia, if she doesn't mind, to just say a few words on yesterday's meeting of the industry committee, yesterday's panel session on industry academic collaboration, and if you had any one or two or three things you wanted to throw out that came out from there.
Thank you, Tariq. Thank you, everybody. Thank you, the panelists also and the participants. This was also a very nice session for me to attend. We have time, actually, if I have a couple of comments for, just 2 comments for the speaker, because I talk about this. Just one thing you mentioned about actually a net present value of research. This was connecting also very well what you were mentioning at the beginning, Tariq, but I see a lot of value in this, actually. Quantify what research can do for industry. This is typically an exercise that an industry will always do. Before starting a project, have a net present value analysis to understand how much this will bring. And this probably will have a lot of, it will be an important thing for the industry committee, I think, to assess. The other, probably my vision on what was just mentioned about also by Dr. Pantazi on the using the model or for cognitive part or also the data learning, I would say that an hybrid of those would be eventually making a lot of sense, because even as biological system, we need to live with both, like data and model. So this could be a good, I see the future also combining, and the chance for what you mentioned about the crown jewel of control, like adaptive or hybrid control, to really surf up and serve this third generation. So quickly, small summary of what we discussed yesterday in the first panel session was about how can we enhance this collaboration. So we identified gaps effectively in collaboration, even though effectively we do want the same things. I mean, academic and industry are working towards the same goal. We identify some intermediate gaps that have to be filled, and our panelists coming from different sectors of industry really shared their experience of how they could bridge those gaps in different sectors and what were the major issues. So we could identify 3 main groups. So will be people effectively that participate into this process. So how can they be trained? How can they sit on the same table and eventually bridge the communication gaps, but also the intermediate goals? Another issue were, of course, processes. How can we make the processes leaner? Also to bridge the time gap differences and the way so that each one can achieve its own final goal. And an important part, actually, that is always underestimated, and we saw that control really lacked this, are the tools. Can we provide effective tools in order to make some of the eye control technology more accessible? Can we provide platforms so that some of the things are easy to test and we can go beyond simulation? We can really quantify how much this control technology can bring. Make it more accessible, actually, for industry to use and to eventually adopt. So this was the summary from yesterday.
Thank you very much. I hope most of you were able to attend the session yesterday. So there were a couple of more things we wanted to go through.
There's no reason to be pessimistic. Things work.
Things work, that's right.
Things are doing what biologists do.
Yes.
My son is a doctor, ophthalmologist. Cutting the eye was a terrible problem. Now doesn't think about it. Only thinks about how to put the exact dioptry, so you are not going to yell at him afterwards. So I tell him, You doctors advance so fine. You are so fine as engineers.
Yes, I think staying positive and optimistic because lots of things work, and we've seen great examples in this session of great accomplishments of control. Actually, so the one question I wanted to ask each of the panelists was, if there was one thing that you think the industry committee should focus on, what would it be? So who wants to go first? If you go first, that means you get the choice of everything. You know, otherwise your points will get taken. Okay, Philippe.
Benchmark, or you call that a tool or platforms? I would call that. Sorry, I would call that a demonstrator. Find a benchmark where we can work together on, even if it is very simple at the beginning. But
yeah, good point, Ricardo.
In terms of papers from industry in Ifac or Ifac conference, I think there should be a kind of understanding of what industrial problems are instead of trying to get industry people to increase their theoretical advantage where there are a lot of advantages in having a real application work, which is very difficult also.
Angeliki.
I think I will go with the discussion that we had here, all these emerging applications, and control engineers and researchers have to look, and maybe there are new methods for control that they are coming, or traditional methods.
So maybe the industry committee should be helping that along in some way?
Or either new methods can evolve, or traditional methods also can find their place to new industrial sectors.
Benny?
I think that it's a lot of PR so industry is moved by the value of the products. If my marketing team will actually know that there is a value, there will be resources and need for that. So kind of we need, if the control theory community is just stuck and only geeks are coming, they don't do any PR. So you have to expose it to non-technical people. If they understand in layman words what is the value, there will be more presence and more industry people will come.
I think my thought is that I'm not sure how feasible this is, but to think about an Ifac publication that actually is so targeted to industry that most of academia is not even really that interested in it. You know, it's just something that helps promote control as this discipline that can have broad-based impact, but not have equations and proofs or anything like that. They're a magazine of some sort that could reach there. So anyway, this is all topic for discussion. And let me quickly, before we conclude, just go over a few plans for the industry committee. So first of all, if you're interested, in participating in the committee, please send an email to me or to Kazuya. We will also be soliciting nominations through the national member organizations and the technical committees. When we get contacts, we will ask people to submit a brief summary of their interest and of their relevant experience. You know, we are particularly interested in people who have worked in industry recently or have had other substantive industry interactions. Of course, we want to make sure we are diverse geographically, that there are all the various industry sectors in which control is involved are represented one form or another, and we're always, of course, short of women in our community as well. And the way things go, the way the process works, we're hoping to have this committee populated by 2017. And then there's a question about what this committee might do. So we've been coming up with a list of possible things, and so this is just a partial list, and some more ideas came up here as well. So articulate what is the value to industry of Ifac, and not just control is one thing, but of Ifac as well. You know, what is supporting your staff to go to Ifac events or publishing in Ifac journals? What does it do for you from an industry perspective? We need to be better at collecting metrics regarding industry engagement. So I showed you some data. We had some caveats associated with it. But if we had a better way of doing that, I think monitoring industry engagement would be a useful thing to do. I also showed you an informal survey we did, doing a survey like that more systematically, putting more thought into it, having a broader pool of respondents, and really getting to the point of what are the successful advanced control applications, perhaps by industry sector, right? And what are the sort of references there that can be pointed to? I think that would actually be very useful for the whole community as well as for outside the community. And all will go to help on the next topic of educating the research community. I think more generally, sort of getting the research community to realize all this complexity that goes into true applications, some of which you heard, much of which you heard about here, you know, certifications and validation and all of that, right? Promoting success stories better, both within and outside the community. Of course, special issues, conference special sessions, roundtables or panel sessions like this. Many Ifac events have been doing some experimentation with getting better industry involvement. I know, for example, the SAFE process conference that Philippe was involved with had some industry sessions at the end of the day that were quite successful. So then there are a couple of other things like that. So we could disseminate some of these best practices across the events. Encouraging industry nominations for particularly the Industrial Achievement Award. This goes back to another topic that came up in these responses, launching a contemporary platform for connecting industrialists and academics. What if there was some platform available where somebody from industry could post a problem or post some data and academics could respond to it, and maybe it could go the other way as well. A webinar series, you know, we all get invitations to webinars all the time, and there are all these fields like big data and smart grid and this and that. What if there was a webinar series, again, targeting industry people and presenting control at the right level for those? And then I mentioned the possibility of proposing a new publication, and this is, as I said, not intended to be an exhaustive list. All right, a final call. We're probably over by a few minutes, just a couple of minutes. If there's any final comments or questions anybody has, or anybody on the panel has. Oh, there is one. Okay, yes.
Thank you for the nice presentation. I am Dipankar Maiti. I'm a student at University of Maryland. So I was hearing a couple of questions and answers, but I did not properly hear one question from the student community. So we are PhD students. We are producing some work. And there has been a huge amount of publications in conference like Ifac and others. And the truth is, like, not all of them are equally important to the community of industry. And as someone mentioned, like, maybe all of them are not necessary because the simple old thing works. So me being a student, almost in my 4th year and going to graduate, so if I want to go to industry, I have always heard these two community, academia and industry. And they quite don't go alone. So me being a student, when I'm transitioning from academia to industry, what path should I follow? What is the suggestions for you guys to the students like me? Because I have been trained in academic domain, and I'm going to serve for an industry. So this missing is sometimes too hard for some students to interpret, comprehend. So it would be very useful for students like me and others. So thank you again.
Thank you for a great question to end with. Who wants to take that on?
I'm just going to give you my call. I don't think that PhD students or any students should be trained to work in industry. I think they should be trained to think and to have the foundations. Eventually, you're going to get into industry. You're going to find your job, and you're going to learn how to work. It's going to be a new environment for you. But I think it would be a waste of time for the industry to come into the academia and start training engineers, because eventually I think every industry has its own niche, its own ways and you're gonna have to learn, but because you have the ability to learn, that's what you need.
I think the other color to put on an answer would be, what do you look for when you're trying to hire fresh PhD students?
I think when you're doing a PhD, you know a lot of things that are interesting for the industry. It's just a way to present what you learned. You know how to communicate, to present your work, make a synthesis. You have a technical background, but if you send a CV or a letter to a private company saying that you work on very theoretical things, they won't be interested. You have to show what you you have learned in your PhD. And I'm convinced that you know a lot of things that are very useful in the industry. It's just a different way to present things and show that you know tools, how to analyze a problem, and don't talk in too much details about what you know about the theory, because industrial, they are afraid about too complex word or too complex theory.
So I think with that, we will conclude the session, and thank you very much for your participation. And again, let us know if you're interested in participating in the technical committee. And please join me in thanking our excellent panelists here.